Hey everybody, here we are with our first Game Salad tutorial and our first tutorial of the semester. In this tutorial I'm going to review some of the things that we went over in Game Salad in class last week. I'm also going to spend a little bit of time going into detail on some things we covered very quickly and introduce a few new things that we didn't talk about in class at all. You should have the Game Salad software installed on the computer that you're watching this on and have the software running so that you can do the things that I'm talking about in the tutorial while you're watching the tutorial. Listen to a little bit of the tutorial, pause it, and try that in Game Salad. If you don't have Game Salad installed and running yet, stop the tutorial now and go and do that first, because it's really not worth your time to just watch this tutorial without actually doing the things that I'm demonstrating in the tutorial. That's how you're going to learn these things. And when you come to class, you're going to be responsible for everything that is in this tutorial. You're going to need to be able to use it in the in-class exercise, plus new information I'll be giving you in class. So it really is quite important that you go through this tutorial carefully with the Game Salad software open. So going into Game Salad, I'm going to create a new blank project. On the project info page, it allows me to choose my platform. You'll usually be working in 720p or MacBook. I'm going to keep it on iPhone 5 because that's just a smaller area, which makes it easier to do the demonstration. Scenes is our panel where we can have multiple scenes in our animation or visual composition or game or whatever it is we're creating in Game Salad. Right now we just have one scene, our initial scene. We'll double click that to enter it. We have an inspector that has two separate panes, a scene pane and a game pane. We'll remain in the game pane for now. The top part of the inspector lets us look at actors, attributes, or devices. We'll stay on actors for the time being. And the bottom part is called the library. That's where behaviors are stored. These are things that actors can do, images and sounds. I've created some images that I'm going to use in this demonstration, and I'll attach those to the email as well so that you have them. I've also found some sounds online, and I'm going to add those as well, so I have some sounds to work with. When you add sounds, they need to be imported. You can import them either as music or sound. Sound are short sounds that are going to accompany actions in your game or animation or composition. Music are longer files. So we want to apply this to all of the files that we're importing and import them as sounds. Once we're in the software, any of these sounds can be previewed with the play button. I create a new actor by clicking the plus button here. I can assign an image to that actor by dragging it and dropping it. I can place the actor on the stage by dragging from the inspector to the stage. By double-clicking the actors, I open up a panel that shows me the actor's attributes, that are things about the actor, such as the actor's color, rotation, and things about its behavior in the world, its physics. Also, when I've double-clicked an actor, the actor's behaviors, basically the program or activities that are running the actor, appear in this right-hand panel. So I'm going to click back on my Behaviors tab of the library and add the same behavior that we added initially, which is the accelerate behavior. Accelerate causes something to, from a standstill, begin to move faster and faster, like a car accelerating or a ball rolling down a hill, or just an object falling. Gravity is a form of acceleration, which is the first type we looked at. Acceleration has a direction, an amount, and a relative to attribute. So a downward acceleration, Game Salad uses 0 degrees as to the right, which means an upward movement is 90 degrees, movement to the left is 180 degrees, and movement down is 270 degrees. And you should just learn these numbers. These are the divisions of 360 degrees. The amount of acceleration is an arbitrary number, where the larger it is, the greater the acceleration. So I'll just drop this down to about 50. And then relative to actor versus scene is an important distinction. I'm going to set it to relative to scene right now. Later we'll look at what relative to actor would mean. So I've created this actor, placed the actor on the stage, and given the actor a downward acceleration, basically subjected the actor to gravity. And I see that the actor falls. As we talked about, you can have multiple copies of the same actor, and by default they will have all of the same behaviors. If you double-click any of the actors that are on the stage, you're confronted with a lock, which is letting you know that if you unlock this and make some sort of change here, like change this to acceleration to at a much higher rate, that change is only going to apply to the single actor being changed. See that one is falling much faster than the others. And if that was an accident, you can always click revert to prototype, and that'll take it back to the locked mode where everybody is the same. And note that this locked versus unlocked version of your actors does not apply to changes in size. When you click on an actor, you can freely change its size without needing to create a new prototype. Also, changes in size, if you hold down the Shift key, will be proportional. I've made this one much larger, but when I double click it, it's still a locked copy of the prototype. The only thing that's been changed is its size. And obviously the same with position. Simply by moving an object, I'm not creating a different version of the prototype. So when I run this, they're all accelerating at the same rate. The next thing we did was create something for them to bounce off of, actor 2. By double-clicking the name, I can change it to floor, and place that actor at the bottom of the screen. In order to make two actors interact, there has to be a collide behavior. Bounce when colliding with actor of type actor 1. Now those actors interact. And the interesting thing that happens here is they collide and push my floor away. So the other thing I need to do is modify the floor so that it has, under its physics attributes, a movable attribute of false. These attributes that have two states are called Boolean attributes, either true or false, yes or no, checked or unchecked, 1 or 0. So we're setting the movable attribute to false, we're setting the movable attribute to 0, and now our floor is immovable. I can place my floor off the screen, and it will appear as if my arrows are bouncing off of the bottom. So if I, for instance, also cause the actors to interact with each other, creating an attribute, creating a behavior in actor 1, that actor 1 can collide, bounce when colliding with any other instance of actor 1. Now our actors will interact with each other. They need to be put in a position where they will collide with each other, like so. And it's worth noting that their pattern of collision is still going to be around the bounding square that they exist within. So we haven't yet made their collision shape the same as their graphical shape. They're going to bounce on each other based on a square. Now, because we set their acceleration relative to the scene, they always fall straight down. So that's gravity as we ordinarily understand it. If instead this were, say, the top view of a bumper car arena, we could set their direction of acceleration relative to the actor. So as they collide and rotate with each other, they will begin accelerating in their new rotated direction. So you see now they've turned to the right, so they're accelerating to the right. This creates a lot of exciting possibilities. Scene direction is absolute. They'll always continue accelerating in that direction regardless of the rotation. Actor acceleration is relative to the way in which they're facing. They're going to accelerate in whatever direction they're facing. So let's add the game functions actor. And I'm going to double click this actor and change this actor's color attribute to red so that we can tell our game functions actor apart from our other actors. And I'm going to put game functions on the stage using the shift key to shrink game functions down to a very small area. Game functions is an actor that usually is going to be hidden, usually off the screen. I'm going to leave this game functions actor on the screen right now just so things are a little bit clearer. And the game functions actor contains behaviors. A behavior that we looked at was the spawn actor behavior. If the game functions actor has the spawn actor behavior, then this actor will give birth to another actor. So wherever our game functions actor is, it will spawn a version of actor 1. And then there's some attributes. Where in front of the actor? Facing in what direction? For instance, if I change this to .45 degrees, my actor is spawned rotated by 45 degrees. And the position, and this direction be relative to the game functions actor. So if the game functions actor was rotated, its rotation would be added to this 45 degrees. Also, the position can either be relative to the scene, where 0, 0 is the lower left-hand corner, and we'll get into coordinates in the next class, or relative to the actor, which means 0 pixels to the right of and 0 pixels above the location of the game functions actor, which means in the same location as the game functions actor. So right now, all the game functions actor is doing is when it comes into existence, it immediately spawns another actor. But if we want it to only perform its behaviors at certain times, we can add a rule. A rule is an if statement, and this is the perfect way to remember it. If there's an if statement with regard to an actor, if this happens, then that happens, then you need a rule. If you can't locate the if statement, you probably don't need a rule. So we could say something like, if I press the space bar, then spawn a new version of actor 1. That's a rule. We say create rule, And the rule reads this way: when all conditions are valid, actor receives event. An event can be something touching it, colliding it, a key being pressed, the mouse button being pressed. We'll use a key. When the actor receives the event key, and using the keyboard button we can select the space bar. When actor receives event key is down, then do this thing. So you see there's a box. The rule is a box. The top half of the rule is the if part, and the bottom half is the then part. If this is the case, then this happens. So now, see, game functions doesn't do anything until we hit the space bar. And when we do, it spawns another actor. And if we hit the space bar again, it does it again. And every time we hit the space bar, we get a new instance of actor 1. Now our situation here is very bouncy. One of the things that we looked at are the physics attributes of objects. So for instance, if I double click the floor, I can go down to its physics where we turned off its movable, and we can also, for instance, reduce its bounciness to like 0.1. And density, friction, and bounciness all interact to create the way in which the objects interact with each other. But, as we talked about, if you drop a bouncy ball onto a hard floor, it'll still bounce. Similarly, if you drop a hard ball onto a bouncy floor, it will still bounce. So actor 1 also needs to have its bounciness lowered. I'll make the bounciness a little bit greater, 0.3. And now, when I hit the space bar, it's spawning a less bouncy version of actor 1. Still a little bounce there. And these actors are sliding because they have low friction. So we can again go into the physics section, increase the actor's friction, and they'll be less likely to slide around. They're still sliding, but not as much. And if we increase the friction more, they could eventually stop sliding. So notice that actor 1 is not on the stage. Actor 1 is only created by game functions. Note that I can actually change the size at which my actor 1 spawns by changing its size, width, and height attributes. The default is 105 pixels wide by 105 pixels high. Since I'm working on a small screen and I just want a smaller actor, I can change it to, for instance, 50 by 50 pixels. And now, when I spawn my actor using the spacebar, it comes in smaller onto the screen. I want to create an actor 2 now, but I want actor 2 to be very similar to actor 1, so I can literally take actor 1, edit, copy actor 1, and paste, and it makes actor 1 copy, who I can then name actor 2, and give his own image, and give an additional behavior. For instance, in addition to acceleration and colliding with actor 1, we'll look at a new behavior, which is change velocity. So this is a momentary application of speed. Since this is an arrow to the right, I'm going to give my actor a change in velocity to the right of amount 100. when that actor is spawned. Now, is there anything spawning that actor right now? No, there's not. So I can go back into game functions, and I can add another rule to game functions. I can create a rule that says when this actor receives event, key is, let's for instance use the letter V. When that key is down, then you can always use that copy and paste trick, and I'll show you another trick also, which is to hold down the Option key, click and drag. That will make a copy of anything on your screen, and that's very common in computers, Option, click and drag. So I'm going to spawn actor 2 when the V key is pressed. So when I hit spacebar, there comes actor 1. When I hit V, there goes actor 2. I'll do the same thing and shrink down actor 2 a bit. Actor 2 has the same default size of 105 by 105 pixels. I'll shrink actor 2 down to 50 by 50 pixels. And additionally, to make the space a bit more interesting, I'm going to make my floor into walls as well, so that these actors are going to be inside a bouncy box. Spacebar gives me actor 1, V gives me actor 2. Interestingly, the walls don't know about actor 2 yet. And this is a great, I'm going to call this now floor wall. So the walls bounce when colliding with actor of type actor 1, and should also bounce when colliding with actor of type actor 2. Now, everybody bounces off of everything, including off of each other. So let's incorporate these sounds, and then I think we've covered enough material. So what if we wanted the floor to make a sound when something contacted it? Our collide behavior doesn't allow that. It would make sense, collide, play a sound when colliding with such and such. But in this case, what we need is a rule. If the actor receives the event overlaps or collides with actor 1, then we can go into our sounds library. Well, first we need a play sound behavior. Play sound. And under sounds, we'll pick a sound. These are all a bit longer than I'd like, but I'll just pick any one of them. That one. And if I want the floor to play the sound when either actor collides with it, I need to make my rule a bit more complex, because right now my rule is when all of these conditions are valid. The floor receives a collision from actor 1, and I can hit the plus key here and say the floor receives a collision with actor 2. But now if I go back up to the top, my rule only applies when all of these conditions are valid. So when actor 1 and actor 2 both collide with the floor, it plays the sound. But what I want is when any of these conditions are valid. So when either this first condition or the second condition is true, the floor or wall will play a sound. And if I want there to be a different sound when the actors collide with each other, I can put a separate rule. For instance, in actor 1, create rule when actor receives event overlaps or collides with actor 2, behavior, play sound, and play a different sound. So now this sound will only occur when actors of two different types collide with each other. Hear the new sound? Now notice that actors of type 2 actually don't collide with each other because they don't have a collision rule yet. That rule would need to be added if we wanted those actors to collide with each other. Actor 2, I can option click and drag to duplicate the rule and bounce when colliding with actor of type actor 1, also bounce when colliding with actor of type actor 2. And here I could create a sound rule for when actor 2 collides with an actor of its own type, we play a sound. So there's our first sound. Here's our second sound. Oh, that's still our first sound. Here's our second sound. And then our third sound is when the actors of two different types. So immediately, we've created something of a musical composition. So these are just some starting points for things to look at in Game Salad, and what your assignment when you come to class is going to be to create 3 totally different visual and sonic, if you can, scenarios for the interaction of elements on the screen. So what we want to do is create 3 really different looking and feeling environments or things happening using these rules and also some other rules that I'm going to show you. Just one other thing that I do want to briefly mention, we're going to discuss it more in class. Right now, our actors are all being spawned in the same place because we have a single game functions. Now we could copy and paste game functions and have game functions and game functions 2, and have actor 1 be spawned in one of our game functions and actor 2 be spawned in the other game functions. Like so. So now spacebar spawns actor 1's over here, and V spawns actors 2 over here. Or, alternatively, I'm going to cut this rule delete game functions 2, put it back in game functions by pasting it, and change the position relative to actor. So actor 1 is going to be spawned 100 pixels to the left of game functions, and actor 2 is going to be spawned 100 pixels to the right of game functions. So spawn position relative to actor, the actor being game functions. So now with just a single game functions, I spawn actor 1 100 pixels to the left, and actor 2 100 pixels to the right. So using these different tools, using these different ideas, I'm going to want you to be creative and be playful, try a bunch of different stuff, come up with a bunch of different visual and sound ideas, and bring a pair of headphones with you to class. Thanks so much for listening, and we'll see you next week.